All right, so today we're diving into something pretty cool.
Yeah.
It's called Gravity Physics by Inquiry.
Okay.
And basically, it's this research project out of Singapore where they're using computer simulations to teach,
Right.
gravity, which can be
Yeah.
a really tough subject
It can be,
for
definitely.
a lot of people
Yeah, for
to
sure.
wrap their heads around.
Yeah, I mean, it's so abstract, right?
Yeah.
Like, you can't
How do you,
see it, right?
you
No.
can't touch it.
It's invisible.
Yeah, you can't send kids to space.
Exactly. You
Yeah.
can't just send them up there.
Not yet, at
Yeah.
least.
Right.
So what are these?
So these simulations are,
What are they doing with these simulations?
yeah, so they're really cool. They basically let students
Okay.
visualize these concepts in a way that you just can't do in a normal classroom.
Right?
So they can play around with orbits and gravitational fields and even launch objects into space.
Yeah.
Wow. Okay. So it's interactive. They
Yeah,
can
well.
actually manipulate things and see what happens.
Exactly.
That's great.
And the really cool part is that
Right.
these simulations are based on
Okay.
real astronomical data.
Wow.
So it's not just like a simplified version of reality.
Yeah.
It's actually, based on the same.
They're working with real physics.
Yeah, exactly.
So
That's pretty powerful.
it is.
Yeah.
And the thing is they're free.
What?
Yeah.
So anyone can use them.
Anyone can
Uh-huh.
use them. They're built using this thing called the Easy Java Simulation Toolkit,
Okay.
which means that anybody anywhere can access them, even adapt them for their own,
Wow, so they're customizable.
Yeah.
That's great.
So you could take these simulations and adjust them to fit your own curriculum or your own
That's awesome.
whatever.
Yeah, that's a huge resource for teachers, especially.
It is a
Yeah.
huge resource who might not have like a big budget for fancy software. Or,
Exactly.
Yeah.
So we've got these simulations, which
Yeah.
are pretty amazing
Yeah.
on their own, but
Right.
the real magic happens when you
Yeah.
combine them with this teaching method called
Cool.
inquiry-based learning.
All right. So tell me about inquiry-based learning.
So basically,
So basically.
instead of just like,
Okay.
lecturing at students,
Yeah.
having
Sit there and passively absorb information.
memorize facts, like
Okay.
inquiry-based learning is all about getting students to ask questions,
Okay.
to form hypotheses, and to test their ideas.
So they're actually driving the learning process.
Exactly.
Okay, that makes sense.
So it's like they're becoming
Yeah.
little scientists.
But they're not just learning about science, they're actually doing science.
Yeah,
exactly.
exactly. And the research shows that this is way more effective than traditional methods because when students are actively engaged,
Yeah.
they're more likely to actually understand and retain the information.
That makes sense.
So it's not just about like,
Right, because if you're just sitting there listening to somebody
yeah,
talk at you, it's easy to zone out.
totally. It's
Yeah.
like, I remember being in physics class and just
Right.
like,
You're thinking about a million other things.
you're
You're
not
not really engaged.
And then, like, the test comes and you're like, I don't remember any of this.
Right, and then you just cram and try to memorize everything,
Yeah.
which doesn't really lead to deep understanding.
No.
Right.
So with inquiry-based learning, the idea is that students are actually, like, constructing their own knowledge
Right.
and making connections. And
They're building their own understanding.
yeah.
Okay.
And that's what makes it so powerful.
So what did the students in this project have to say about this approach?
So they actually,
Like, did they enjoy it?
they loved it.
Really?
Yeah. They said things like, it makes us look at the results, analyze, and then find the trend, which is, a really good way to learn independently.
That's awesome.
And they also said these kinds of lessons force us to think critically,
Right.
which, I mean, that's really.
That's what we want, right?
yeah.
We want students to be able to think critically,
Exactly.
not just regurgitate facts.
That's what's.
So it sounds like this approach is really working.
Yeah, it really is.
That's exciting.
It is.
Okay, so they have these simulations. They're using inquiry-based learning.
Yes.
What are the specific simulations they developed for this project?
So they actually developed 4 main
Okay.
models,
Yeah.
each targeting like a different aspect of gravity physics.
All right, I'm curious. Tell me about them.
So the first one
Yeah.
is all about geostationary orbits.
Okay, so those are the orbits
Inter-
where a satellite stays above the same point on Earth.
Yes,
Okay.
exactly.
Got it.
And so with this model, students can adjust
Mhm.
parameters like the satellites,
Right.
altitude and velocity,
Uh-huh.
and then observe how those changes affect its orbit.
So they can actually see, like if they change the altitude, how does that change the orbit?
Exactly.
Okay.
And it helps them understand that delicate balance of forces that keeps a satellite in that fixed position.
So it's like a hands-on way to understand those concepts.
Exactly.
That's really cool.
Yeah, it's really neat.
Okay, so what about the other models?
So the next one is called
Okay.
two-mass model.
Two-mass model.
And it's a little bit more abstract.
Okay.
But visually, it's really cool.
All right. I'm intrigued. Tell me more.
So basically, imagine being able to actually see the gravitational fields and the potential lines between two objects.
Okay, got it. Yeah.
With mass.
So you can see how the gravity is actually affecting...
Yeah, so you can... Students can literally see how the strength of the gravitational force changes as you move the objects closer together or farther apart.
That's a great way to visualize something that's, you know, invisible in real life.
It is.
Yeah.
And it really helps drive home the point that gravity isn't just this, like, mysterious force that we can't understand. It's something that we can...
Right, something we can actually measure.
Yeah, measure and model and
study.
Yeah.
Okay, cool.
So it's pretty neat.
So what's the third model?
The third model is the Earth-Moon model.
Earth-Moon model. Okay.
And it focuses
on that one too.
The concept of escape velocity.
Okay.
So, you know, if you want to launch a rocket...
Right. Into space. You got to go fast enough.
You need to give it enough speed to overcome Earth's gravitational pull.
Yeah, otherwise it just falls back down.
Exactly, like throwing a ball straight up in the air.
Yeah.
But not hard enough.
Exactly. And so this simulation lets students experiment with launching objects from Earth towards the moon.
Okay.
And they can adjust the launch speed and angle and see what happens.
So did they hit the moon? Do they
reach the moon?
Fall back to Earth?
Do they fall back to Earth? Do they
go into orbit?
Caught in orbit.
Oh, that's cool.
So it's a really great way to understand the relationship between velocity and gravity.
Yeah, I like that.
Yeah.
Okay, and last but not least,
we have Kepler's third law system model.
Kepler's third law system model.
And this one...
what's that one all about?
Well, Kepler's third law describes the relationship between a planet's orbital period, which is the time it takes to go around the sun.
Right, the time it takes to complete one orbit.
Yeah.
And its distance from the sun.
Okay.
So this simulation lets students collect data on different planets and then analyze that data to rediscover Kepler's third law.
So they're actually like doing the science themselves.
They are.
Yeah.
It's not just about, you know, seeing a formula on a page.
Right, they're not just memorizing a formula. They're actually figuring out how it works.
And experiencing how that formula plays out in the
real world.
Yeah. So it's pretty cool.
I like that.
Yeah.
So we've got these 4 amazing simulations.
Yeah.
They sound really cool.
But it doesn't stop there.
Okay, there's more.
All right.
What else is there?
This project also dives deep into the pedagogical design principles.
Okay, so they're not just throwing the simulations out there. They're actually thinking about how to use them effectively.
Yeah, so they're drawing inspiration from research done at places like Open Source Physics and ADSHE-ET.
I've heard of HET, yeah.
And they're really trying to make sure that these simulations aren't just flashy distractions, but are truly integrated into a thoughtful pedagogical approach.
Okay, so tell me more about how they're actually using these simulations in the classroom.
All right, so that's where the inquiry part of Gravity Physics by Inquiry comes in.
Okay.
So these simulations are specifically designed to be used in conjunction with Physics by Inquiry and modeling instruction strategies, both of which emphasize active learning.
Right, so it's all about...
And student-driven investigation.
Getting the students involved, getting them engaged, not just passively listening.
Exactly. So it's not a case of like, here's a simulation, go play.
Yeah, go have fun.
You know?
But actually learn something.
There's a real structure and purpose behind it.
Yeah.
So the researchers have actually developed like a whole curriculum around these simulations.
So they've really thought this through.
They have, with detailed lesson plans and activities.
So they're providing teachers with everything they need to actually implement this.
Exactly.
That's fantastic.
And they've been offering workshops to train teachers on how to...
Great. So they're supporting teachers in making this transition.
Exactly.
That's awesome.
So it's really...
they're really committed to making this work.
They are really committed to making this approach accessible and sustainable.
That's fantastic.
Yeah. Here we go.
Okay, so we've talked about the simulations. Yeah. We've talked about the inquiry-based learning approach.
Yes.
But I want to hear more about the student experiences.
Okay, so...
What was it actually like for the students who participated in this?
Poised to focus, because ultimately... This is all about the students, right?
It is. It is.
So the research included some really compelling quotes from students who participated in the project.
Okay.
One student said, normally people would have to experience any physics concepts themselves through hands-on to really remember concepts. Lectures, on the other hand, may not be effective.
Right.
Since maybe what the lecturer is bringing through is unclear.
Yeah.
And thus, practical lessons to learn concepts is a great learning deal.
I love that quote.
Yeah, it's really insightful.
Yeah, it really highlights the importance of hands-on learning.
It does.
Even if it's hands-on in a virtual environment.
Yes.
You know, it's about experiencing the concepts for yourself.
Yeah.
Not just trying to absorb them passively.
Exactly.
That's really powerful.
And it really makes you think. Like, could this approach be applied to other subjects as well?
Exactly, because if it works for physics, why not history or biology or, you know, any subject where...
Yeah, any subject where it's hard to...
There are complex ideas or abstract concepts.
Visualize.
Yeah,
exactly.
That's a great point.
So there's a lot of potential here.
There is.
But let's get back to the student feedback.
All right, what other feedback did they have?
So,
besides, you know...
Another student said, these kinds of lessons force us to think critically.
Yeah.
It makes us look at the results, analyze, and then find the trend within, which is a really good way to learn independently.
Yeah.
It also gives us confidence and a sense of accomplishment.
That's great.
When the conclusions we arrive at are correct.
I love that.
Yeah, so it's not just about, you know, learning the right answer. It's about developing.
It's about the process.
The skills and confidence to become...
It's about feeling empowered.
A lifelong learner.
To figure things out on your own.
Yeah.
Yeah, that's fantastic.
It is.
That's really what we want.
And that's a perfect note to end on for part one.
Okay.
We've covered a lot of ground.
We have.
But...
Yeah, there's more to explore.
Much more to explore.
All right, so stay tuned for part two.
Stay tuned for part two.
We'll dive even deeper into the student experiences, the challenges of implementing this approach, and the potential it has to really transform education as we know it.
Exactly.
I'm excited.
Me too.
Right. All right. So welcome back to our deep dive into gravity physics by inquiry.
It's great to be back.
We were just talking about the incredible impact that these simulations are having on students.
Yeah, it's really inspiring to see how excited they are about physics.
Yes.
You know, it's like they're seeing it with new eyes.
Yeah.
It's not just about the fun factor either.
No, not at all. There's real depth to the understanding that they're gaining.
It's not just about, you know...
They're not just memorizing facts.
Yeah.
They're developing critical thinking skills.
Yeah.
Problem-solving abilities. A deeper appreciation for the scientific process.
Yeah.
It's amazing.
One student even said, these kinds of lessons force us to think critically. It makes us look at the results, analyze, and then find the trend within.
Wow.
Which is a really good way to learn independently.
That's powerful.
Yeah.
They're not just learning about gravity.
Yeah.
They're learning how to learn.
Exactly.
That's incredible.
Which is like a lifelong skill.
Absolutely.
Right.
That's going to serve them well no matter what they do.
Totally.
Yeah.
So we've talked a lot about the successes.
Yeah, the positive side.
Of this project. But I'm also curious about the challenges.
Okay, yeah.
You know?
Sure.
Were there any hurdles that the researchers had to overcome?
Yeah.
So any feedback from students?
It's interesting because even with all the positive results, the research doesn't shy away from the challenges.
Okay.
They actually talk about them quite openly.
Okay.
And
which is great.
One thing that came up repeatedly was the need for well-structured inquiry activities.
That makes sense.
You know, the simulations themselves are a tool.
Yes.
They're not.
It's up to the educator to
a magic bullet.
Yeah, exactly.
It's up to the educators to design activities that actually guide the students towards meaningful learning outcomes.
Yeah. It's
But you can't just giving someone a hammer.
Throw a simulation at a student and expect them to
doesn't mean they know how to build a house.
learn physics.
Right, exactly.
Right.
You have to give them
You need to provide them with the structure and the support.
the plans, the instructions.
Yeah, exactly. And the students in this project, they really highlighted that. They said things like, we need clear instructions, we need well-defined goals, and we need activities that actually challenge us to think critically.
That's great feedback.
Yeah, and apply what we're learning.
So they're not just...
Yeah, they're not just passively...
like, along for the ride.
Absorbing information.
They're actively shaping.
Right, they're actively involved.
The experience, I imagine that requires a different approach to lesson planning.
It definitely does.
Right.
It's a shift from a teacher-centric model to a more student-centered one.
Yeah.
The teacher becomes more of a facilitator.
Okay.
Guiding the students through the process of inquiry and providing support along the way.
I like that.
Rather than being the sage on the stage, lecturing at them.
Yeah.
They're more of a guide on the side.
Yeah, exactly.
So it's a different way of thinking about teaching.
It does sound like a big adjustment for some teachers.
It is.
It is, for sure.
You're used to.
It can be challenging.
That traditional model.
Yeah.
The sage on the stage.
The researchers recognize that.
Okay.
That's why they've put so much emphasis on professional development.
Yeah.
They've been offering workshops and creating resources to help teachers implement this approach effectively.
That's amazing.
Yeah, they're really committed to supporting teachers.
It sounds like they're really thinking about the long-term sustainability of this approach.
They're in it for the long haul.
Yeah. Were there any other challenges?
So some students also mentioned areas where the simulations themselves could be improved. For example, they suggested making the interfaces more user-friendly and the visuals even more engaging.
Okay, I can see that.
Yeah, and some even suggested adding a gamification aspect.
Yeah, I remember you mentioned that. Yeah, like adding points and rewards.
Right, yeah.
To make it even more fun.
Yeah.
And engaging.
And I think that's really interesting feedback.
It is.
Because it shows that...
It highlights the importance of listening to the students.
The students are part of...
Right. They're the ones who are using these tools. They're the ones
who are experiencing it firsthand.
Who are learning.
Yeah.
So their feedback is invaluable.
And it's so valuable.
Right.
It's like a feedback loop.
Yeah, exactly.
Where the students are actively contributing.
It's a collaborative process.
To the improvement.
Yeah, and that's how it should be.
Of the learning tools.
Absolutely.
Which is really cool.
It is.
As we're talking, I'm just struck by how this research really flips the script.
I know, right?
On traditional notions.
It's like a paradigm shift.
Of education.
Yeah.
It's not just about memorizing facts or solving equations.
Right.
It's about
fostering a love of learning.
Yeah.
Encouraging exploration.
Yeah.
And empowering students to become critical thinkers and problem solvers.
Exactly.
It's a whole different way of thinking about education.
It is, and it makes me rethink.
Me too.
Like my own assumptions about
really just
what education can be.
Yeah. About what learning should look like.
And it's exciting to think about the potential ripple effects.
It's not just limited to physics either.
Yeah.
Right.
This approach could be applied to so many.
It could be used in
different subjects.
Any subject.
Yeah.
Where there are complex systems or abstract concepts that are hard to grasp.
Yeah.
So the potential is huge.
Gravity physics by inquiry isn't just a project.
Yeah, it's not just
like a one-off thing.
Movement. Yeah, I think you're right.
You're right.
It's a movement towards a more engaging, more effective, and more student-centered approach to education.
And that's
something we can all get behind.
We can all get behind.
Whether we're students, teachers, or just lifelong learners.
Or just people who are curious about the world.
Exactly. So, before we move
on to the final part.
To the last part of our deep dive.
Yeah. I want to just take a moment.
Okay.
To reflect on what we've learned so far.
Yeah, we've covered a lot of ground.
We have.
We've explored this really innovative approach.
Yes.
We've delved into the research behind it. We've heard from students about the impact it's having.
Yes,
and
we've
seen how this approach is not without its challenges.
Right.
But the researchers and educators are committed to addressing those challenges and continuously improving the learning experience.
They're not like shying away from the hard parts.
No, they're embracing them.
They're like, oh,
they're saying, okay, we know there are challenges. Let's figure out how to overcome them.
How do we make this even better?
Exactly.
So what's next? What else can we learn from this research?
In the final part of our deep dive, we're going to explore the broader implications of this project.
Okay, great.
We're going to ask questions like, what does this tell us about the future of education?
Yeah.
What other areas of study could benefit from a similar approach?
Yeah.
And most importantly, how can we all apply these principles of inquiry and exploration to our own learning journeys?
Awesome. I can't wait.
Me too.
Welcome back to the final part of our deep dive into gravity physics by inquiry.
Yeah.
You know, we've seen how successful this approach is in Singapore.
Right. But where do we go from here?
Yeah.
What's the bigger picture?
What are the broader implications?
Exactly.
You know, as we've been talking about this project.
Yeah.
I just keep thinking about all the subjects I struggled with in school.
Yeah. Oh, yeah.
And I wonder if this approach could have made a difference.
It makes you wonder, doesn't it?
It really does.
Like, imagine if history class wasn't just about memorizing names and dates, but about...
Like, what if you could...
stepping into a virtual world.
Yeah.
And experiencing those events firsthand.
Experience ancient Rome.
Yeah, exactly. Walk the streets of...
Or walk the streets of revolutionary Paris.
Yeah.
It would be incredible.
That would have been amazing.
Yeah.
Or imagine learning about biology.
Right. By interacting with a virtual cell.
Yes.
You could zoom in and see all the different organelles.
And how they work together.
You could even experiment.
Yeah.
With different conditions.
Like, what happens if you change?
Yeah. And see how the cell responds.
Yeah.
I mean, the possibilities.
The possibilities are endless.
Are pretty much endless.
It seems like you could apply this to almost any subject.
Any subject where there are...
Where you have complex systems or abstract concepts
exactly.
that are hard to grasp.
What other possibilities?
Well, I'm particularly interested in the potential for this kind of learning.
Okay.
In STEM fields.
Okay.
Imagine, students designing and testing virtual bridges.
In engineering.
Yeah, in engineering.
Like a virtual wind tunnel.
Exactly.
It's so cool.
Or modeling climate change scenarios.
Right.
In environmental science.
That's a great idea.
So it's really about moving away from that traditional model of education.
Where you're just...
as a passive process of absorbing information and moving towards something more active, more engaging, and more empowering.
Exactly.
And it's not just about the content.
Right.
It's about the skills.
It's the skills that we're developing.
You develop along the way.
Yeah, like critical thinking, problem solving, collaboration, creativity.
Those are the skills that you need.
Those are the skills that are, no matter what you do,
essential for success in the 21st century.
That's exactly.
No matter what field you go into.
Like, it's a toolkit for...
It's lifelong learning.
Giving them a toolkit for lifelong learning. Yeah. They're not just learning about a specific subject. Right. They're learning how to learn how to ask questions.
How to find answers.
How to adapt.
That could be adaptable.
To new challenges.
Yeah.
And that's what makes this research so exciting.
It is.
It's not just about improving education in Singapore.
Right.
It's about inspiring a global shift.
Yeah.
And how we think about teaching and learning.
And one of the things that I think is so great about this project is that the researchers are so committed to making their work accessible.
They really are.
The simulations are free.
Yeah.
They're offering teacher training workshops.
They're sharing their findings, their resources.
They want other people to...
with the world.
Yeah, they want this to spread. They really believe in this approach.
Me too.
And they want to see it benefit students everywhere.
That's fantastic.
Yeah, it's really inspiring.
It is.
To see that kind of commitment and generosity in the field of education.
I think that's a great takeaway for our listeners.
It is.
You know, we've explored this world.
We've explored this fascinating world.
Of gravity physics by inquiry.
Yeah.
But the real journey...
it begins now.
The journey continues.
As we all consider how we can apply these ideas.
Yeah, how can we take these ideas...
to our own lives.
And our own learning.
To our own lives and our own learning experiences.
So as you go about your day, you know, ask questions.
Be curious.
Seek out new challenges.
Explore.
And never stop exploring.
Never stop learning.
The world around you.
Yeah, keep that sense of wonder.
With a sense of wonder.
And curiosity alive.
And if you're interested in learning more about gravity physics by inquiry,
check out the links in our show notes.
Yeah, we'll have all the information.
You'll find information about the project.
About the project, the simulations.
The simulations, the researchers.
Yeah.
Everything.
So thank you for joining us.
Thank you for being here.
On this deep dive.
We hope you enjoyed it.
We hope you found it.
We hope you found it as thought-provoking.
Thought-provoking.
And inspiring as we have.
Until next time.
Keep those brains buzzing.
Keep learning.
Happy learning.